So this is a bust of Hadrian from the British Museum, a plaster cast. He was a Roman emperor who obviously built the Hadrian's Wall in Britain. And I chose it because it's very typical of Roman geometry. And the whole idea of this is to show how the business of copying from probably a terracotta original that would have been a portrait made from the emperor himself, probably as many as 50 copies of that likeness would have actually been used in one workshop in order to have it always looking more or less the same. And the point of this is to show how the geometry of copying has actually influenced artists, not only sculptors, but draftsmen and painters throughout Europe for a very long time in a way that is not really recognized by the art historians. We know, because I've placed this measuring boss on a very prominent curl on Hadrian's head, right in the middle of his forehead there. And we know that the Greeks from about 470 BC onwards were measuring from some original. We don't know what the original was, but they were definitely measuring. They weren't going by eye, which, for instance, at Chartres or somewhere like that in medieval times, they didn't do copies. They were carving directly as they thought fit, whereas in Roman portraits they're all very much more naturalistic. And in the case of Hadrian, we know that in fact they managed to get a likeness virtually every time. From this measuring boss, one would first of all take measurements from the original, and then you'd bring it here. There's always a cross on the boss, and you can measure the length of his head, for instance. You can measure where his jaws are. You can measure the width of his jaws, going backwards and forwards from the original to this. And as a result of that, you will have a feeling for particular high points from which the geometry develops. Of course, with marble, you'd be starting from a block. And the interesting thing is that the design of this bust is absolutely based on the size of the block. And if I, for instance, put this along the front of his chest so it touches there and move it up to here, this touches a curve here, and you can see that that line becomes the axis of symmetry of the block, of the head. And furthermore, if we cut that away, which we don't need, then an apprentice would be got to just cut that away. You can see how that shape and that shape are very much reflected in the head itself. So what would happen after the block, the smaller block, had been cut? You cut away these things here and you're left with the smaller block. They would make a kind of egg shape through here, round the edge of his ears and under his chin, and the same on the other side here. You feel how that all fits in there. the egg is still visible there. So I've just built up that corner of the block so that you can see how cutting planes there and there actually leave you this sliver of stone on which you can mark out where the bottom of the eyebrow is, where the bottom of the nose is, where the mouth is, and obviously where the chin is. And so that is a practical thing, and you see, for instance, how, we take these away, the pyramid of the nose, which is made by those planes cut off there, is reflected actually in the corners of the mouth and reflected in the furrows of his frown here. So that shows how Romans came to love the geometry rather than just use it as a practical entity. And what I feel about Roman portraiture is that it's got this, you can still feel the oval, you can still feel the block, you can still feel the front of the original block, and within that they go on and on. For instance, cutting a plane here, they've actually gone too far and chipped the ears on both sides, cutting these planes to find the head within this smaller block. A friend of mine described it as frozen music, and I think that's very apt. Artists have always recognized the geometric quality of the head, for instance, and here's Bridgman's famous book on drawing from life. You see how he's used the geometry of the head to define the head itself. He's not using the egg, he's using geometry. One more wedge shape is cut out, where here we cut and come to the chip in the ear and cut up there. And that will give us the main outlines of the